What's up guys, welcome back to another Grand 75 video walkthrough. Today we're going to be going over LeetCode number 297, construct binary tree from preorder and inorder traversal. Given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree, construct and return the binary tree. So given this tree here, we're given two lists, the preorder, which goes 3, 9, 20, 15, 7, which follows a preorder traversal. That basically goes current, left, and right. So the current would be 3, the left would be 9, and then because there's no children of 9, we go to the right node. The current is 20, the left is 15, and because there's no children of 15, we go to the right node of 20 again, and then we just write 7. And then inorder would just be left, current, and right. So we keep going down left until there's no node to process, and then we, add it to this list. So the list goes 9, 3, 15, 20, and 7. And given these two lists, we are actually able to fully construct the binary tree, and this is how. So the solution here is going to be a recursive DFS solution, and we know that the first node in the preorder list must be the root node. So what we can do is we can immediately create a tree node with this value, and then we can find the index of the root value in the inorder list. And what we can do is set this index to mid, and now we can set the left pointer of this new tree node to be the left recursive call, which has parameters of the preorder list indexed from 1 to mid plus 1, and the inorder list indexed from 0 to mid. And if you think about it, this makes sense, especially the inorder, because the inorder lists the nodes sequentially. So everything to the left of the root node in the inorder list is going to be belonging to the left subtree, and vice versa for the right subtree. And mid plus 1 just happens to be the index that all elements that belong to the left subtree in preorder are below. And the opposite applies for the right subtree. It's just a recursive call to preorder of mid plus 1 and anything above that, and then inorder of mid plus 1 and anything beyond that as well. So going over an example here, we have the same tree, and we have these two lists. So we can see that 3 would be the root node, so instantly we can instantiate this, and we find that 3 is index 1 in inorder, so we make mid to be index 1, and now the left recursive call would be the preorder list indexed from 1, so starting at 9 all the way to mid plus 1, so this would be 2. However, because the right index is exclusive, it would simply just be 9. And then for the inorder list, it's just anything below 3, so we just have 9. And now we have a new recursive call with the preorder of 9, inorder of 9. So this one is pretty straightforward. It would just be a node of 9 here, and mid would be 0. However, trying to index this list, so this would go from 1 to 2. However, 1 is out of bounds for either of these. So what we would do is just ignore the next two recursive calls that would be made here, and go to the right pointer recursive call, which would be, for preorder at least, it would be mid plus 1 to the end. So we have 20, 15, and 7. And for inorder, we would simply skip 3 and go to 15, 20, and 7. So Again, the same thing applies. The first element in preorder is the root node, so we make a tree node with value of 20, and 20 is value 1 in mid, so write that as 1, and then we take 1 to mid plus 1 for the left recursive call, so that would be 15, and because it's exclusive, it would just be that, and we would simply take 15 again here, and for the same reason as 9, there's no more recursive calls made from here, and we create 15 for the left pointer, and now we go to the right pointer, so mid plus 1 and on is just 7, and then it's 7 as well for the Inorder list, and we can simply write 7 here, and those are all the recursive calls that are made. So at the end of the algorithm, we have the exact same tree, except it's a new object, and pretty straightforward algorithm using preorder and inorder list to recreate the tree. Thanks for watching.